Hi everyone. In this video I wanted to just give a pretty quick overview of statistics, and this is going to do a nice job giving you an idea of what we're going to start off with in chapter 1. So there's two things here, this y and this idea of probability, and basically this really is going to be a kind of a pretty quick overview of sections 1.1 and also 1.5. So 1.1 and then a little bit of 1.5, and then this is also in sections 1.1 or section 1.1. So this will kind of get you started. Then you can start looking at the book, you can start looking at the other resources, the weekly activity, the homework problems, all that stuff. So okay, statistics. What is going on here? What is this class? What is this thing I hear about constantly? Well, the way that we're going to use statistics is we are going to try to use it to answer questions. So whenever you're talking about statistics, you have to just start with some big question. Okay, and so, if you're interested in psychology, sociology, the medical field, many of the sciences, then, you maybe already thought of this. There's a question you want to answer, okay? And so depending on the field you're in, there's a question. How do I answer it? Well, the way we answer the question is we usually want to measure something. So we're going to measure something, okay? And when I measure something, that's going to help me answer the question. So this is where statistics comes in. And specifically it comes in with this picture right here that we see to the side. So we have this picture here, and usually what happens is you ask a question, and this question you ask, you usually ask it about some big group, about some big, I won't even call it a group, I'll just call it a thing. Right? So if you're in the social sciences, you're usually interested in people for the most part, right? So you're interested in learning about people. And so the groups of people can be different. Maybe you're interested, if you're into politics, you're interested in adult Americans. That could be a group of people you want to learn about. Or maybe you're interested in families. Maybe in a different part of the world, you're interested in a different group of people. Maybe you're interested in kids. There's all these different things. So that's the thing you could be interested in. Right? If you're in the medical field, you could be interested in the effectiveness of a drug. And so what we do in statistics is we say, okay, here's your question. I'm going to get you an answer, or I'm going to try to get you an answer, and I'm going to measure something. And what I'm going to do is I'm going to measure something about the big thing. The big group is a lot of the times what we'll deal with. So it doesn't always have to be a group of people, but frequently it is. So you ask a question about a big group, I am going to measure something, or I try to measure something about that big group, and if I measure it, then you're going to go, okay, I think I understand, at least something more about my question. Well, where statistics comes in is that's really hard. This whole idea here that we just wrote, this whole thing, this is hard, right? Think of the examples we just said. Does it really seem plausible or easy or doable to try to ask a question about all adult Americans, hundreds of millions of people? That sounds hard. So statistics comes in when we want to take the step of, I really want to learn about these people, this big group. I want to learn about them, but I just can't ask them all. So what I do is I say, okay, I'm only going to grab some of you. So see these dotted groups here, these dotted circles here. This is called sampling. So this is the idea of sampling. In statistics, we say we can't get the whole big, clear picture. So instead, let's take a smaller picture that we can do, and then that's where statistics comes in. We're going to use the statistics to try to say, okay, I understand the small group. I've measured something about the small group. How does that help me learn about the big group? And immediately you should think, well, I wasn't able to ask everyone, so I can't know anything perfectly. You've got it. That's big. But we're able to talk using the math. We're able to talk about how confident are we. If we can't be 100%, how confident are we that we've got a measurement that's close to the right answer? How far is close? All these questions are things we can use math to help us understand. But the real big picture idea is I want to ask a question about a big group called the population. This big thing, this is called the population. Okay? I want to ask a question about that. So I'm going to answer it for you by measuring something about this population. This measurement, this thing that I'm actually going to measure right here, this has a name. It's called the parameter. So the parameter is a measurement of the population. And there's a specific few types of measurements that you'll get into in section 1.1. Okay? And the format of how we do a lot of stuff is the same no matter what, but different situations call for different ways of measuring. But that's the idea. We've got a big group. We want to measure something, parameter. That's a number that describes, aka measurement, that describes the population. And it's our goal to try to understand this measurement. Okay? Statistics is about that. If you want to then take that measurement and try to build on it, to build the sociology on it, to make a medical determination, that's where your other fields come in. That's where your other classes take over. But for us, it's just, can we learn about this number we're after? And again, it's hard. So what do? We, just like in the picture, we take a small group or small thing, and we'll see some examples where it's not people, so it'll make sense why I'm saying small. So we'll take a small group and we'll still measure about them. We'll still measure the same thing we want to measure to answer the question, but we actually can get our hands on this. Up here, I can't measure the height as an example for hundreds of millions of people, but instead I can look at a sample of maybe 100 people and I can measure their heights. And that's the idea. That's the whole idea. That's it. There's a population, a big group or set of things I want to learn about. How do I learn about them? I calculate something. I measure something about them. That's too hard. Too many people, too many things. What do? I say, you know what? Let me just get a couple. Give me a couple people. I can grab them. Maybe don't grab them, but you know what I mean. I can get them, and I can measure that same thing that I want to do up here. But I can actually do it for the sample. And I get a number, and that number helps inform me about my question. So that's it. You got the big group, population. You say, too big, give me a small group, sample. You say, oh, I want to answer this question, so I'm going to measure something, parameter. But darn it, I can't get to that big population. So I instead measure only about my small. That's called a statistic. So, I think this gets tough because it's almost like there's only two things, the group and the measurement. Yet because I'm talking about two different groups, the big and the small, there's actually 4 different things here. And that can get tricky. But here's what we're going to do. We're going to practice it and practice it and practice it. Example, example, example. So if you're not feeling sure at the beginning, that's okay. We're gonna get there. So boom. That's kind of like statistics as a whole, right? So we're going to spend a whole semester attacking this idea, which is, interesting and also kind of weird, but that's it. That's the whole big thing. So this I'll call easier. Okay, so then I put up another thing here, though, probability. And this comes in when we're trying to understand this measurement that I keep talking about here. Because it's not just that we're going to try to measure a number, try to measure something and say, I'm done, look, here's my measurement. We also are going to use math, and we're going to take the measurement that we have, the measurement, aka the statistic, and what we're going to do, it's great, it's amazing that we can do this, the statistic, we are going to say, I actually know this number. I know this number, the statistic, from this group of people that I've talked to. And then what I'm going to do is I'm going to be able to say, okay, I think I know the answer, the parameter. So I have a guess for, get rid of this, the parameter. So, pretty often you have some guess for the parameter, which remember, what's the parameter? It's the measurement about the big group. So maybe you're interested, is the average height of people in the U.S. or adults in the U.S. this number? You have that in your mind. You're like, I wonder if it's this. What we're going to do is we're going to take a measurement from just some people, and then we're going to ask the question, okay, I know the average height of these 1,000 people. Do these work together? Do these two fit? Does this make sense? Does my measurement make sense of my 1,000 people if the parameter, the average height of the big group, is really some number? And so maybe that sounds a little bit weird. This is why we're going to start off actually not focusing on people and focus on kind of silly things. So let me give you a more in-depth example of probability, and we'll kind of see where we can go with this. So you're going to see in this class right at the beginning, because it's a little easier to wrap our heads around, this idea of studying probability in terms of coin flips. So a big example is coin flips. We're going to be talking about coin flipping a lot, okay? So, okay, let's just recap. What do we know about coin flipping? We know that if you have just a regular old coin and you flip it, you can get heads or tails, and then the chance is 50% for each. There's a 50% chance you get heads, 50% you get tails. So, okay, these are our parameters. That's our little connection we're thinking about here. And you might be thinking, well, what do you mean? Where's the population? This is a little tricky, but our population in this case is all the coin flips of this coin that could ever be and ever will be. Infinite coin flips. It's kind of crazy to think about, but think about it for a second. You often hear fair coin. What do we mean by that? We mean what we wrote down. A fair coin, 50% of the times will be heads, 50% tails. So if I just walked up to you and said, here's a coin, prove to me it's fair, what would you do? Well, it's kind of a weird question, but maybe you would say, I'll flip it. Okay, how many times would you flip it? And maybe you'd say 100, and I would say, okay, but how do you know that that's actually enough to prove, without a doubt, that this coin is going to be 50% heads, 50% tails? So maybe you'd say 1,000, 100,000, 1,000,000. And the idea is, well, even if you do it 1,000,000 times, right? Even if you do 1,000,000 times, there's still a tiny chance that even if you get 50-50, this coin could not be fair. And so it's a weird thing to think about, because on our usual lives, and even in the science community, we never care, even though we'd like to, right? We don't usually care too much about having to find out we are 100% right about something. And in statistics, this is going to be a shock. We are never actually going to be certain that we're never going to be 100% certain of anything we claim, any conclusion. And that's just something we have to live with. Because again, we can't look at every coin flip that could ever be. We can't ask every adult in the U.S. a question. So we'll never be 100% certain. And so this idea of 100% certainty would be like having to flip the coin forever and looking, heads, how many heads, how many heads, how many tails, what proportion. We can't do that though. So what we do instead is we say, okay, you know what? 100 flips, let's do it. That's fine. What is this? This is the sample. This is, I can't look at all of them, but 100, I can look at 100 and tell you what happens. So let me just give you some hypothetical answers to this. Like, what could happen? I flip a coin 100 times, and I get 50 heads and 50 tails. Okay, so here's my question. If this was a fair coin that I had, I don't talk like this normally. I'm being purposefully, slow and meaningful when I say this. If it is a fair coin, what do you think about my results? 50 heads, 50 tails. So you might say, yep, that sounds right, because 50 out of 100 is 50%. Look at us go. We've nailed it. 50% heads. Cool. Okay, great. So I'm feeling pretty confident I got a fair coin. Can I prove it 100%? No, but come on. Probably fair. All right, what about a second scenario? What if I got 45 heads and 55 tails? Someone walks up to you and says, I got a coin, I flipped it, I got 45 heads and 55 tails out of 100. What do you think? And you're probably sitting there like, well, it's not perfect, but come on, it's a coin. There's random chance, right? That it's not going to be perfect necessarily, and that should be okay. I agree. This is up here. Woohoo! This is okay. Not perfect. It's not a perfect 50-50, but close enough. Close enough. Okay. All right. So, okay. Got it. All right. But what if I did it again and I was like, actually, I got 25 heads and 75 tails? Then you might say, are you sure you're telling me it's a fair coin? And you flip that. And maybe your gears are turned. You're saying, I don't know about this. Like, this seems a little iffy. And if you're at that point, you have just done it. Like, this is the last piece of the puzzle, really, of statistics, is this ability, is to say, if the coin is fair, right? If I'm really flipping a fair coin right now, this outcome, this data right here, what we just got here, right here, is very unlikely. So think about that, read it over, say it out loud. If you can convince yourself that, yeah, you believe that, then you're right there. Like, this is it. This is the idea, right? If I come up to you and say, here's a fair coin, and then we flip it together, and I get 25 out of 100 heads, 75 tails, and you're sitting there thinking, I really don't think this is a fair coin, you've just done the entire logic of statistics. You've got it. That's the whole idea. So that's what we are going to do with this. We're going to try to learn about big groups, lots of times people, but not always. How are we going to learn about them? So we'll scroll back up. That's not scrolling. We're going to measure something, okay? But darn it, I can't actually measure this parameter. So instead, I'm going to take a sample and get the statistic, measure just from the smaller. And then I'm going to say, well, okay, I've got this number from the smaller group. So, okay, that's good. But then remember, there was a question you had, and often the question comes along with something that we're interested to know about the parameter. Is the coin 50-50? Does the drug, have less people with side effects compared to the other drug? And what we're going to do is we're going to, just like the coin flip, we're going to say, okay, let's pretend it's a fair coin. Let's pretend the drug doesn't do anything. Let's pretend insert whatever. And then we're going to look over here at our statistic, our data, and we're going to go, okay, sure, fits fair coin. All right, that's fine. And we're going to look at this data. Okay, that seems to fit. Fine, fair coin, sure. And we're going to look at this data, and then you're going to go, Mr. B, I think you got sold a not fair coin. And I'm going to tell you, why was I buying coins in the first place? And that's another conversation. But the whole point is, if you can get on board with this idea, which we'll practice, I promise we're going to practice it a lot, and then we're going to slowly integrate it into like actual statistics with people and things like that. But if you can get on board with this idea, assume the coin is fair. and then look at your data and say, does that really fit what should happen in my mind for that? You're on the right track. And that, combined with this understanding here of population sample and being able to pick out these things in a problem, that's the whole course. So, I'm making it maybe sound smaller than it is because I'm sure many of you have heard, statistics, math, blah. But come on. Once you get your head around it and you practice it and you work hard at it, you can do it. And then once you've got statistics under your belt, there's so much you can do. It's amazing. So much you can learn. So we're going to practice this. We're going to work hard. Go do the reading. Look at the things that I've posted. Start just playing around the homework, the computer homework. Get your practice with the symbols. They're very important. The symbols. We got to have that down. So get working, get going, and I'll see you in class.